In the autumn of 1845, farmers in Ireland walked into green potato fields and found a smell of decay rising from the soil. Plants that had looked healthy days earlier collapsed into blackened leaves. When the tubers were lifted, many were already rotting. This was not just a failed harvest. Millions of people had built their survival around one crop, grown in a narrow range of varieties, inside an economic system that left the poor almost no margin for error. The potato had helped Europe grow richer, larger, and more urban. Now the same crop seemed to reveal a terrifying weakness. How had a plant from the high Andes become powerful enough to feed cities, support armies, reshape populations, and then help turn a plant disease into a national catastrophe? To answer that, we have to leave 19th century Ireland and travel thousands of years backward to a landscape where the potato was not bland, uniform, or ordinary. It was wild, bitter, diverse, and difficult, and the people who transformed it were solving problems that Europe had not yet imagined. High in the Andes, farming is an argument with altitude. Nights can freeze, days can bring intense sunlight, rain may arrive at the wrong time, or not at all. A field that thrives at one elevation may fail a short distance higher. Yet around Lake Titicaca, on the borderlands of modern Peru and Bolivia, communities began domesticating wild potatoes roughly 8,000 years ago. The first potatoes were not the smooth, predictable tubers stacked in a supermarket. Wild species could be small, knobby, intensely bitter, and rich in natural defensive chemicals. Those chemicals helped the plant survive insects and animals, but they could make the tubers unpleasant or unsafe for people. Domestication was therefore not a single discovery. It was a long partnership between farmers and plants. Generation after generation, Andean growers selected tubers with useful traits: better flavor, lower bitterness, larger size, different maturity times, resistance to frost, and the ability to grow at particular elevations. They did not create one perfect potato, they created diversity. That distinction matters. In the Andes, diversity was not decoration. It was insurance. A family might plant several kinds because one tolerated cold, another resisted drought, another stored well, and another tasted better in a particular dish. If weather destroyed one, the others might survive. The colors alone could fill an artist's palette: cream, gold, red, purple, blue, nearly black. Shapes ranged from round to twisted, finger-like, or deeply indented. Today, more than 4,000 native varieties are still associated with the Andean region, the living result of centuries of farmer knowledge. But cultivation solved only part of the problem. Fresh potatoes contain water. They can sprout, rot, or be ruined by frost. A crop that feeds people only at harvest time is useful. A crop that can wait through winter, travel, or survive a bad season is civilization changing. Andean communities developed one of the great storage technologies in food history, chuño. At high altitude, winter nights freeze potatoes naturally. Daylight thaws them. Repeated freezing and thawing breaks down the tubers. They can then be pressed or trodden to remove water, dried in the intense mountain sun, and stored as a light, durable food. The process does not look futuristic. It uses cold air, heat, time, and sunlight. Yet in principle, it is a form of freeze-drying, an answer to the same problem modern food engineers solve with expensive machinery. The technique also reveals something important about the people behind the crop. They were not simply selecting a plant and hoping for the best. They were designing an entire food system around uncertainty. Fields were distributed across elevations. Planting dates could be staggered. Different tubers were assigned different uses. Some were eaten fresh, some were dried, some were reserved as seed. Knowledge of frost pockets, soils, and seasonal signals passed through families and communities. The potato, therefore, became more than a species. It became a collection of decisions. Even its method of reproduction created opportunities and risks. Farmers usually plant pieces of tuber rather than botanical seed. The new plants are clones of the parent, which preserves a successful combination of traits. A good potato can be multiplied again and again with remarkable consistency. But cloning also preserves weakness. If every plant in a field shares the same vulnerability, a disease that can attack one may attack them all. The ancient Andean answer was not to abandon cloning. It was to clone many different potatoes. That balance, consistency within a variety, diversity across a landscape, would later be lost in places that wanted one crop to behave like a uniform industrial material. Chuño could be carried, traded, stored, and cooked long after harvest. It helped communities build reserves against crop failure. Later, Andean states, including the Inca Empire, connected agricultural zones through roads, terraces, storehouses, labor obligations, and systems of redistribution. The potato became part of a larger machine of survival. It was not the only food in that world. Maize, quinoa, beans, peppers, and other tubers all mattered. But the potato had a special relationship with difficult land. It could turn cold slopes into calories. When Spanish invaders entered the Andes in the 16th century, they were searching for wealth they could recognize, especially gold and silver. The potato did not glitter. It grew underground. Its greatest value was easy to miss. Spanish colonization violently disrupted Andean life, but it also began moving American crops across oceans. Potatoes reached Europe in the second half of the 16th century, probably through more than one route. They appeared in Spain, then in botanical collections and gardens elsewhere. At first, the potato was not treated as the future of food. It was an exotic plant. European botanists were fascinated by its flowers and puzzled by its habits. The plant belonged to the nightshade family, alongside edible tomatoes and peppers, but also species with poisonous reputations. Its visible berries were not food. Its useful part hid beneath the soil. For societies accustomed to judging grain by its stalks and seed heads, the potato seemed botanically suspicious and culturally backward. In some places it was fed to animals. In others it remained a garden curiosity. Religious rumors, medical doubts, and simple unfamiliarity slowed adoption. But the biggest obstacle may have been more practical. The potato had evolved near the equator, where day length changes little across the year. Northern Europe's long summer days and shorter growing season demanded adjustment. The potatoes arriving in Europe had to become European. The name changed as the crop moved. European languages compared it with truffles, earth apples, and sweet potatoes. Confusion was understandable. The ordinary word potato passed through a history of mistaken identity, blending names used for different American tubers. Cooking knowledge had to travel too. A crop is not adopted merely because seed arrives. People must learn which part is edible, when to harvest it, how to store it, what damage makes it unsafe, and how it fits existing meals. This process often happened below the level of official history. Gardeners exchanged tubers. Soldiers carried them. Sailors valued foods that survived voyages. Monasteries, estates, and botanical gardens tested unfamiliar varieties. Rural households observed which plants endured poor soils or wet summers. The famous promoters mattered, but adoption was ultimately accomplished by unnamed growers. They adjusted planting depth, chose seed tubers, learned to earth up soil around the stems, and discovered which harvests survived the cellar. By the time governments claimed success, farmers had already done much of the biological and practical work. Historical DNA has revealed part of that transformation. Early European potatoes were closely related to Andean landraces. Over time, they mixed with potato lines connected to Chile and acquired traits better suited to forming tubers under long northern days. Farmers were not merely moving a crop across a map. They were reshaping its biological clock. That adaptation took generations. It also explains why the potato's conquest of Europe was slow, uneven, and often misunderstood. There was no single moment when a king, scientist, or clever publicity stunt persuaded an entire continent to eat it. There were campaigns, however, and they left behind wonderful stories. In Prussia, Frederick the Great is associated with orders encouraging potato cultivation, especially in a kingdom repeatedly threatened by war and grain shortage. In France, Antoine-Augustin Parmentier became the crop's most famous champion after encountering potatoes during wartime captivity and later promoting them through experiments, publications, and elite support. A widely repeated tale says Parmentier planted a field near Paris, guarded it conspicuously during the day, then removed the guards at night so curious people would steal the supposedly valuable plants. It is a perfect marketing story, perhaps too perfect. The details are difficult to prove. The broader truth is less theatrical and more important. Governments and reformers promoted potatoes because grain systems were fragile. Wheat and rye were visible above ground, vulnerable to bad weather, armies, and requisition. Potatoes produced heavily on small plots and kept their treasure beneath the soil. Peasants did not always resist because they were ignorant. New crops carry risks. Seed stock may fail, instructions may be wrong, landlords may demand adoption while leaving farmers to absorb the losses. People had rational reasons to distrust agricultural advice from officials who did not share their hunger. But repeated wars and food shortages changed the calculation. Once local varieties adapted and cooking knowledge spread, the potato offered something remarkable: more food from land that might produce poor grain. A household could boil it in one pot. It required less milling and baking infrastructure than bread. It supplied energy, vitamin C, potassium, and other nutrients. Combined with milk or other foods, it could support a surprisingly adequate diet for people with few alternatives. The potato began moving down the social ladder and then, paradoxically, lifting populations upward. Across parts of Europe, it became associated with peasants, laborers, miners, soldiers, and the urban poor. Elites sometimes mocked it as coarse food. Yet coarse food can carry an economy. Every acre producing more reliable calories reduced pressure somewhere else. Families could survive on smaller holdings. Towns could draw food from wider and more productive agricultural systems. One influential economic study later estimated that the potato accounted for roughly a quarter of the growth in population and urbanization across the Old World between 1700 and 1900. That estimate is debated like any large historical calculation, but the mechanism is clear. Higher agricultural productivity can support more people and free more workers to live in towns. The potato did not single-handedly create the Industrial Revolution. Coal, machinery, trade, empire, finance, labor systems, and many other forces mattered. But cheap, dense food helped create the conditions in which industrial cities could expand. By then, the potato was no longer an Andean curiosity. It had become infrastructure. And nowhere did that transformation go further than Ireland. Potatoes arrived in Ireland by the late 16th or early 17th century. The climate suited them. More importantly, the crop suited the lives forced upon many rural families. Under a deeply unequal land system, large numbers of poor tenant farmers survived on small plots. Grain and livestock often served rent, trade, or markets. Potatoes could feed a family from a patch of ground that would not provide enough bread grain. This was the crop's triumph and the beginning of its danger. The Irish case also shows why nutrition cannot be separated from power. On paper, potatoes produced an impressive amount of food, but the people eating them often did not own the land beneath the crop. Rent, debt, and the threat of eviction shaped every planting decision. A family could improve a patch, harvest well, and still remain insecure. If the household expanded, holdings might be subdivided into smaller plots. The potato made those smaller plots temporarily workable, which allowed the population to keep growing without removing the underlying inequality. This is one of history's cruelest patterns. A technology can relieve suffering while postponing reform. The same productivity that protected families from ordinary hunger also allowed the political system to tolerate extraordinary poverty. Because people survived, the structure appeared sustainable. Because the crop worked so well, its success concealed how little protection existed if it failed. When blight arrived, there was no simple replacement. Grain required more land and processing. Livestock could not instantly multiply. Wages were scarce. Relief depended on decisions made by officials who disagreed about responsibility, markets, public expense, and whether aid would create dependence. The crisis became a test not only of agriculture, but of whose survival the state considered its duty. Imagine a rural household with little land, little cash, and no secure reserve. The potato is not chosen because it is fashionable. It is chosen because the alternatives fail the arithmetic of survival. A small field can produce a large amount of food. The family eats potatoes daily, often with milk when available. Children grow up on them. Population rises. From a distance, the system looks efficient. Up close, it is a trap. Dependence did not mean that every Irish person ate only potatoes or that only one variety existed, but poorer communities relied heavily on a narrow genetic base, including widely grown types that were highly vulnerable to the same disease. Poverty reduced the ability to diversify. The land system rewarded output without creating security. A good crop allowed people to endure conditions that remained structurally precarious. Then, in 1845, late blight arrived. Phytophthora infestans is not a true fungus, though it behaves like one to the eye. In cool, wet conditions, it spreads rapidly through foliage and tubers. Spores travel. Leaves darken. Stems collapse. Tubers may appear sound at harvest and rot later in storage. For a farmer, the horror was speed. A field represented months of labor and nearly an entire winter's food. Then the plants changed color, the air filled with the odor of decay, and the harvest seemed to dissolve underground. Crop failure alone does not fully explain the Great Famine. The disease struck elsewhere in Europe too. Ireland's catastrophe grew from the interaction of blight with mass poverty, insecure tenancy, limited relief, public policy, and a market system in which food existed, but many people could not command enough of it. The potato did not betray Ireland. The system around it failed millions of people. Between the census of 1841 and that of 1851, Ireland's population fell by about 1.5 million through death and emigration. The losses did not stop at the shoreline. Families were separated. Communities were emptied. Ships carried migrants to Britain, Canada, the United States, and beyond. Those migrants carried memory with them of hunger, landlords, relief works, eviction, disease, and political abandonment. The famine altered Irish nationalism and poisoned relations with British rule. It reshaped cities across the Atlantic, where Irish communities built churches, unions, newspapers, voting blocs, and family networks. A plant disease had exposed an empire's social structure. It also changed science. Researchers argued over whether the blight came from weather, decay, fungi, or some other cause. The germ theory of disease was still developing. Plant pathology barely existed as a modern discipline. The crisis forced closer attention to how crop diseases spread and how uniform fields could magnify risk. The lesson was not simply never depend on potatoes. All civilizations depend on crops. The deeper lesson was that efficiency without diversity can become fragility. Europe had received only a fraction of Andean potato diversity. Farmers had then concentrated on types that fit local tastes, climates, and markets. Uniformity made planting and selling easier. It also meant that one successful pathogen could find field after field of similar hosts. In the Andes, farmers had spent centuries creating a portfolio. Industrial agriculture preferred a product. After the famine, breeders searched for resistance. New varieties moved through global networks. Scientists collected wild potatoes and land races, looking for traits that commercial crops had lost or never possessed. The center of origin became important again, not as a romantic birthplace, but as a genetic library. Meanwhile, the potato continued spreading. The crop's expansion outside Europe was not a simple second wave of European influence. Farmers everywhere evaluated it according to local needs. In the Himalayan highlands, potatoes could occupy cold environments where many crops struggled. In parts of Africa, they became valuable near cities because a high-value harvest could be moved to urban markets. In Central Asia, they entered irrigated valleys and mountain farms. In China, they spread through regions where altitude, poor soils, or short seasons limited other staples. Each adoption created a different potato economy. Some focused on household food, some on seed tubers, some on street markets, some on processing. The crop could improve food security, but it could also expose farmers to unstable prices, expensive seed, storage losses, and diseases carried through planting material. A potato is bulky and easily bruised. Unlike dry grain, it is mostly water. That makes transport costly and storage technically demanding. The global potato trade therefore grew not only through ships and roads, but through warehouses, ventilation, temperature control, grading, and eventually refrigeration. The underground crop required an above-ground empire of logistics. In China, India, Africa, Central Asia, and other regions, it entered different farming systems for different reasons. In some places, it became a highland staple. In others, it fit between grain harvests, produced food quickly, or provided cash for small farmers near growing cities. Its identity kept changing. It could be peasant food, military food, famine relief, street food, industrial raw material, or restaurant comfort. War repeatedly demonstrated its practical strengths. Potatoes could grow in cool climates and produce substantial food in a short season. Because the edible tubers were underground, a field might escape some forms of destruction or confiscation that ruined standing grain, though armies could certainly seize potatoes too. During the two world wars, governments encouraged household and institutional cultivation. Lawns and ornamental grounds were turned into productive plots. In 1918, even part of the grounds at Britain's Royal Botanic Gardens, Kew, was plowed for potatoes. The crop's old advantage returned. When supply chains break, local calories matter. But the 20th century did something new. It separated the potato from the field almost completely. For most of history, a potato looked like a potato when it reached the kitchen. Industrial processing changed that. Machines washed, peeled, sliced, shredded, dehydrated, froze, flavored, packaged, and standardized it. The potato became an ingredient that could disappear inside another product. Its starch thickened foods and helped make adhesives, paper coatings, textiles, and other materials. It could be converted into glucose or dextrin, fermented into alcohol, or fed to animals. A tuber bred for frying was no longer judged only by flavor. Processors cared about shape, dry matter, sugar content, bruising, storage behavior, and how evenly it browned. The potato was being designed for machines. What makes the potato so productive is not magic. The leaves capture sunlight, manufacture sugars, and send much of that energy downward into swollen underground stems, the tubers. Because the harvest is largely water and starch, potatoes can deliver substantial food quickly, especially in cool conditions. But that biology creates constraints. Tubers breathe after harvest. They lose water. Warmth encourages sprouting. Cold storage can alter sugars and affect frying color. Light can turn the skin green and increase defensive glycoalkaloids. Every stage from field to kitchen is a negotiation with a living organ that has not realized it is supposed to be a finished product. Modern storage facilities slow that life without completely stopping it. Processors monitor temperature, humidity, bruising, and sugar levels because a potato that looks acceptable to a shopper may behave badly in hot oil. The uniform fry is therefore a biological achievement as much as a mechanical one. Consider the potato chip. The popular American legend credits George Crumb, a celebrated cook in Saratoga Springs, New York, with inventing it in 1853 after an angry customer complained that fried potatoes were too thick. Crumb supposedly sliced them paper-thin out of spite, only to create a sensation. It is a satisfying origin story. Irritation, revenge, accidental genius. It is also probably not true in that form. Recipes for thin-fried potato slices appeared before 1853, including an English recipe published in 1817. Other Saratoga cooks may have made similar dishes. Crumb did become strongly associated with Saratoga chips and helped popularize them, but no single dramatic plate can carry the whole invention. The myth survives because industrial food likes a founder. Agriculture rarely provides one. Chips required more than a clever cook. They needed reliable frying oil, mechanical slicers, packaging, transportation, advertising, and retail networks. Early chips were often sold locally because they went stale and broke easily. Better bags and mass distribution turned a restaurant specialty into a national snack. French fries underwent an even larger transformation. Fried potato strips existed long before modern fast food, and Belgium and France both occupy the cultural argument over their origin. In the United States, fries spread through restaurants and popular culture, but hand-cutting and frying potatoes created inconsistency. Different tubers contained different amounts of water and sugar. Storage changed their behavior. A restaurant chain needed the same fry in every location. In the mid-20th century, processors developed frozen French fries that could be partially cooked, frozen, shipped, stored, and finished quickly. J.R. Simplot's company became central to that system in the United States. Frozen fries matched the needs of expanding quick-service restaurants: speed, uniformity, low kitchen labor, and predictable cost. The potato had once helped households survive without mills or ovens. Now it helped restaurants serve millions of identical meals. That change is visible in American consumption. Fresh potato availability declined across the late 20th and early 21st centuries, while frozen products, mostly fries, became dominant. By the early 2020s, roughly half of U.S. potato availability was in frozen form. This is a strange final stage in the potato's social climb. The food once dismissed as primitive became a triumph of logistics. A modern fry may begin with a variety selected for processing, grown under contract, harvested by machine, stored under controlled conditions, scanned for defects, cut at high speed, blanched, dried, partially fried, frozen, transported across long distances, and cooked on demand. The result is so familiar that the system disappears, and that invisibility creates a modern misunderstanding. The potato itself is often blamed for the nutritional profile of the products made from it. A plain potato is low in fat and provides carbohydrates, fiber, potassium, vitamin C, and other nutrients. A heavily salted fried product is a different food system built around the same tuber. History keeps changing what the potato means. In the Andes, it meant diversity and survival at altitude. In 18th century Europe, it meant agricultural reform. In industrial cities, cheap nourishment. In Ireland, both life and vulnerability. In 20th century America, convenience. In today's global market, it can mean all of those things at once. The scale is enormous. Potatoes are cultivated in more than 100 countries. Global production reached a record of about 383 million metric tons in 2023. More than 1 billion people eat them regularly, and developing countries now produce more than half of the world's crop. Yet the future of the potato may depend on returning to its oldest lesson. Commercial agriculture favors uniformity because uniform crops are easier to plant, harvest, process, price, and market. A French fry factory does not want 4,000 unpredictable shapes and colors arriving at the loading dock. It wants a tuber that fits the line, but heat, drought, salinity, pests, and plant diseases do not care about factory efficiency. As climates shift, the traits needed tomorrow may be hidden in a bitter wild potato growing on a remote slope or in a farmer's local variety that never entered international trade. That is why gene banks and farming communities matter. The International Potato Center in Peru safeguards thousands of potato accessions. Scientists use cultivated varieties and wild relatives to search for resistance to late blight, bacterial wilt, viruses, heat, drought, and other stresses. Modern genetic tools can identify useful traits faster, but the raw material still comes from diversity created by evolution and protected by people. In Andean communities, farmers, many of them women who maintain seed knowledge across generations, continue planting native potatoes in complex mountain environments. Their fields are not museum displays. They are active laboratories where taste, climate, culture, and survival meet. The relationship between scientists and farmers is not always simple. Genetic material has moved through histories of conquest and unequal trade. Credit and benefits have not always returned to the communities that conserved valuable crops. Modern conservation works best when it treats those farmers not as background characters, but as experts and partners. There is an irony here. Europe once received the potato and narrowed its diversity to fit new systems. Now researchers around the world return to the Andes and to wild relatives, searching for the variation that uniform agriculture removed. The future may need the past it tried to standardize. New breeding methods can produce varieties that mature faster, resist disease, tolerate heat, or use water more efficiently. Disease-resistant potatoes could reduce farmers' dependence on fungicides. Better seed systems could prevent viruses from accumulating as tubers are replanted year after year. But no variety is permanently invincible. Pathogens evolve, consumer preferences change, climate zones move. A crop is not secured once and forever. Resilience is a process. That brings us back to Ireland in 1845. The blackened fields are often remembered as the moment the potato became a villain. But the potato was never the villain. It was a brilliant solution placed inside a dangerously unequal and genetically narrow system. For thousands of years, this plant has rewarded human intelligence. Andean farmers learned to tame bitterness, match varieties to altitude, and preserve harvests with mountain frost. European farmers adapted it to long summer days. Poor families used it to pull nourishment from tiny plots. Scientists learned from its diseases. Engineers turned it into starch, snacks, and a frozen global commodity. At every stage, the potato solved a problem. And at nearly every stage, the solution created a new dependency. That is why the history of the potato is larger than food. It is a history of what humans do when we discover something efficient. We spread it, we simplify it, we build systems around it, we forget the knowledge that made it resilient. Then, when the system is tested, we rediscover the value of diversity. Today, a potato can be a purple heirloom exchanged between mountain families, a seed sample frozen in a gene bank, a staple in an African highland market, starch in a sheet of paper, or a perfectly uniform fry handed through a car window. They are all chapters of the same biography. The next time you see a plain brown potato, remember what is hidden inside it: an Andean experiment 8,000 years long, the rise of cities, the memory of famine, the machinery of fast food, and a genetic archive that may help feed a hotter world. The potato became ordinary only after changing almost everything around it. Subscribe for more hidden histories. Tell me which potato dish carries your family story, and give the video a like if this changed how you see the humble spud.